Dear students, so in this class now let us discuss about a non-linear first order PDE, non-linear first order partial differential equation. So consider a non-linear PDE, it's of the form f of x, y, z, pq equals 0. Consider a first order non-linear partial differential equation f of x, y, z, pq equals 0. Without loss of generality, we can assume that fq is differs from 0. Thus, we can solve this equation f of x, y, z, pq equals 0 at each point triplet x, y, z for q as q equals q x, y, z, p. Since f of fq differs from 0, then we can solve the given first order PDE f of x, y, z, pq equals 0 at each point triplet x, y, z, at each point x, y, z as q equals q x, y, z, p. Now let x naught y naught, x naught y naught, triplet x naught y naught z naught be any point in the given space. Now we consider a possible integral surface z equals zxy, possible integral surface z equals zxy, and the direction ratios triplet p, q, minus 1 to the normal or direction ratios of the normal to this tangent plane. Then z minus z naught equals p into x minus x naught plus q into y minus y naught at each point. Okay. Then the Monge-Kohn equation. The Monge-Kohn equations are given by q equals, the Monge-Kohn equations are given by q equals q x, y, z, p. Then z minus z naught equals p into x minus x naught plus q into y minus y naught, and x minus x naught by fp equals y minus y naught by fq. So the Monge-Kohn equations are obtained, or the Monge-Kohn equations are q equals q x, y, z, p, which is nothing but the solutions of the given f of x, y, z, p, q equals 0. And consider the line which is, or tangent plane which is normal to the integral surface, which is z minus z naught is p into x minus x naught plus q into y minus y naught, having direction ratios p, q, minus 1, p, q and minus 1. And x minus x naught by fp equals the characteristic equation x minus x naught by fp equals y minus y naught by fq. This is obtained by differentiating this f of x, y, z, pq equals 0 with respect to p. Why? Here fp equals 0 means dy by or df by dp equals 0. Dy by df by dp means fp plus fq into dp by dq equals 0. Okay. So the Monge-Kohn equations are this one. So how to find out the Monge-Kohn? We have to solve these equations. So in order to find out the solution of a Monge-Kohn, we have to solve these three equations. Q equals q x, y, z, p, and the line having, or the tangent plane having direction ratios pq minus 1 which is normal, that is z minus z naught is px minus x naught plus qy minus y naught, as well as the characteristic equation x minus x naught by fp equals y minus y naught by fq. So consider an example. Consider here p square plus q square equals 1. Find the Monge-Kohn. Find the Monge-Kohn of p square plus q square equals 1 with the initial points x naught, y naught, z naught equals 0, 0, 0. X to p square plus q square equals 1. The initial arguments sx naught, y naught, z naught equals triplet 0, 0, 0. How? Here the given equation is p square plus q square equals 1. Here x naught, y naught, z naught is 0, so we have z equals px plus qy. From here where we know that the Monge-Cohn equation is z minus z naught equals p into x minus x naught plus q into y minus y naught. Here x naught and y naught are zeros. So it is z naught is also 0. So z is px plus qy. Okay. And the third one is x minus x naught by fp. The third one is x minus x naught by fp equals y minus y naught by fq. Okay. So that is x minus x naught by fp. What is fp? Here f is, what is f? F is identically, it is p square plus q square minus 1. This is f. Okay. So what is fp? Fp is 2p. And what is fq? Fq is 2q. Okay. This is f4. P square plus q square minus 1, which is identically equal to 0. Enough. So x minus x naught by fp, 2p equals y minus y naught by fq. It is 2p. Then for Monge-Cohn obtained by Monge-Cohn is obtained by eliminating p and q from these three equations. The Monge-Cohn equations are q equals q x y z p, and z minus z naught equals p into x minus x naught plus q into y minus y naught. Moreover, x minus x naught by fp is y minus y naught by fq. So in order to find out the Monge-Cohn of a given surface, we have to eliminate this p and q from these three equations. So it is given, we have p square plus q square is 1, z is px plus z equals px plus qy, and from here x naught and y naught are zeros. So here it is x by p equals y by q. Two and two cancelling each other. So that means qx minus py equals 0. Qx minus py equals 0. On solving this, so here if you multiply it with a q and it with a p, so it is p such equals p square x plus pqy, and second one with the q, so it is 0 equals q square x minus pqy. If you are adding, then p such equals p square plus q square into x. But p square plus q square is 1, so that means x equals p such. That means p equals z by q. Sorry, p equals z by x. Sorry, p equals x by z. Similarly, you can solve by multiplying. Then similarly, you can solve. You have y equals q such. That implies q equals y by such. Again, we know that p square plus q square equals 1. So that means p square, it is x square by z square plus y square by z square is 1. That is x square plus y square equals z square. So this is the required Monge-Cohn. So the Monge-Cohn is obtained by eliminating p and q from the Monge-Cohn equations. Q equals q x y z p, that is taken as f, and z minus z naught equals p x minus x naught plus q y minus y naught, as well as x minus x naught by fp equals y minus y naught by fq. Okay. Now, so this is the method to find out the Monge-Cohn of a given surface. Now, as the line of contact between the tangent plane to an integral surface, the Monge-Cohn at that point is given by x minus x naught. We have, it is x minus x naught by fp. We know that x minus x naught by fp equals, this is the one of the Monge-Cohn equation. X minus x naught by fp is y minus y naught by fq. Moreover, we have z minus z naught equals p into x minus x naught plus q into y minus y naught. Okay, so here the line of contact to the tangent plane to an integral surface, and the Monge-Cohn at that point is, here it is x minus x naught by fp equals y minus y naught by fq equals z minus z naught by, it is p fp plus q fq. From this equation, z minus z naught, x minus x naught equals some p into fp, and y minus y naught q into fq. So from here it is x minus x naught by fp equals y minus y naught by fq equals z minus z naught by pfp plus qfq. Okay. Suppose it is some dt. What happens here? So x minus x naught equals x minus x naught by fp, y minus y naught by fq equals z minus z naught by pfp plus qfp. Hence the characteristic directions which lie along the generators of the Monge cone are given by, it is triplet. The generators of the Monge cone are given by triplet fp, fq, pfp plus qfp. This is the generators of the Monge cone. Okay, the generators of the Monge cone are given by triplet fp, fq, pfp plus qfp. Then hence the characteristic curves. So what are the characteristic curves? The characteristic curves are the solutions of the equation. Characteristic curves are the solutions of the equation dx by dp, dx by fp, not dp, dx by fp equals dy by fq equals dz by pfp plus qfp. Okay, suppose it may be equals some dt. So what do you get? We have dx equals fp into dt, or dx by dt equals fp. Dx by dt equals fp. Dy by dt, what is dy by dt equals fq, and the dz by dt equals pfp plus qfp. So this is the characteristic equations. So the characteristic equations are the solutions of this one. Dx by dt equals, dx by fp equals dy by fq equals dz by pfp plus qfp. Let it be dt. Then we have dx by dt is fp, dy by dt is fq, and dz by dt is pfp plus qfp. But actually, what is dp by dt? dp by dt means it is dp by dt. dp by dt means it is px into, or dp by dx. dp by dx into dx by dt plus dp by dy into dy by dt. Why? Because p is pxy. Okay. So that means dp by dt is px into dx by dt. dp by dx is stated as px into dx by dt plus py into dy by dt. Okay. Similarly, what is dq by dt? dq by dt is similarly dq by dt is, it is px into dq by dt is, it is it is qx into dx by dt plus qy into dy by dt. Okay. So dp by dt and dq by dt are in terms of px, py and qx, qy respectively. Agree. Now also consider the first equation, that is f of x, y, z, p, q equals 0. Consider this equation. So differentiate this with respect to x. What do you get? If you differentiate it with respect to x, you have first term df by dx, that is fx. Then plus z is in terms of p, x and y, so it is fz into p plus fp into px plus fq into qx equals 0. Okay, f of x, y, z, p, q equals 0. P is in p of x, y, q is in p of x, y, z is z x, y, and so f of x, y, z, p, q equals 0. So it is then if you differentiate it with respect to x, so it is fx plus fz into dp, p into fz df by dz, fz into p plus fp into px plus fq into qx equals 0. Similarly, if it differentiate with respect to y, what do you get? It is fy plus it is fy plus fz into q plus it is fp into qx plus fq into fp into px py plus fq into qy equals 0. Okay, fp into py plus fq into qy equals 0. But we know that py equals, what we have, py equals qx. So on substituting, we have, by using these two ideas, means fx plus fzp equals, what is fx plus, fp into px, fp into px, py equals qx. So it is yes, fp into px plus fq into py, fp into px plus fq into py equals minus fx minus fz into minus fx minus fz into p. So means dp by dt, from these two conditions we have dp by dt equals minus fx, dp by dt equals minus fx minus p into fz, and dq by dt minus fy minus q into fz. Okay, so consider the number of these such equations. This is immediate from here, dp by dt. What is dp by dt? Px dx by dt plus py dy by dt. That is px into dx by dt. What is dx by dt? From here, it's also dp by dt equals px into dx by dt. Dx by dt is fp plus py into dy by dt fq. This is same as dq by dt, means qx into dx by dt fp plus qy into dy by dt fq. Okay, so by using these two ideas, means fp into px plus fq into py, fq into py, qx is py itself, that is minus fx minus fzdp. So that is dp by dt is minus fx minus p fz. Okay, similarly dq by dt is minus fy minus qfz. Clear? So then, in order to determine the integral surface, consider the system of all of these equations. So to determine the integral surface, we have to consider system of all these equations. So the equations are f of first one. Then to determine the integral surface, consider the equations f of x, y, z, bq equals 0. This is the first one. Second one is dx by dt is fp, comma dy by dt equals fq, and dz by dt equals pz by dz by dt equals p fq plus q, sorry, p fp plus q fq, sorry, as p fp plus q fq. Okay, again we have these equations. Thus the next consider equation is this one, dp by dt is, sorry, this one, dp by dt is minus fx minus p fz, dq by dt is minus fy minus q fz, comma xt, yt, zt, pt and q of t all are unknowns. So in order to consider, or in order to determine the integral surface, we consider the system of these equations. That is f of x, y, z, bq equals 0, dx by dt is fp, dy by dt is fq, dz by dt is p fp plus q fq. Also, dp by dt is minus fx minus p fz, dq by dt is minus fy minus q fz. Moreover, this xt, yt, zt, pt and q of t are unknowns. Okay, so this is the method to find out the integral surface. So in order to determine the integral surface, we have to solve all of these equations. Clear? Now there's a characteristic strip. So a solution to the all of these equations, which are the solution. Now we consider the equations. First one, f of x, y, z, pq equals 0. First equation. Then similarly, the next one is dx by dt equals fp. comma dy by dt equals fq, comma dz by dt. dz by dt is pfp plus qfq. Then also dp by also it is dp by dt equals minus fx minus p of such. dq by dt equals minus fy minus q of such. Then df by dt, or as in we hear the xt, yt, zt, p of t and q of t, all are unknowns. So the solution of the characteristic equations or a solution to these equations is an integral as a strip. A solution to these equations can be interpreted as, not integral, interpreted as a strip. So the solutions of these equations. In order to find out or in order to determine the integral surface, we have to consider these equations. So the solution of this system of equations is known as a strip. The solution of this equation is known as a strip. Okay. So now let us consider the condition for a strip conditions. So a strip condition means a set of 5 functions xt, yt, zt, p of t and q of t can be interpreted as a strip only if it satisfies the strip condition dz by dt of t equals p of t into dx by dt of t plus q of t into dy by dt of t. So these 5 unknowns, x of t, 5 functions or 5 unknowns, xt, yt, zt, p of t and q of t can be interpreted as a strip. We also know that, or we already said that, the strip is nothing but the solution of this system of equations. Here, if you solve these equations by using this x of t, y of t, z of t, p of t and q of t, it is interpreted as a strip if it satisfies a strip condition, that is dz by dt of t is p of t into dx by dt plus q of t into dy by dt. So moreover, the strip condition is generally taken as it is dz naught by ds equals p naught into dx naught by ds plus q naught into dy naught by ds.